Hi guys, in this video we are going to look at resistance. First we will define what resistance is, then explore the factors that affect resistance. After that we will discuss resistivity, and finally we will look at how resistance is measured. Resistance is the opposition to free flow of electrons. The opposition to free flow of electrons is caused by the attractive bonds between electrons and protons, as well as the collisions between electrons as they move through a material. Materials are made up of atoms, and atoms are composed of three particles that are electrons, protons, and neutrons. Protons and neutrons are contained inside the nucleus of an atom, and electrons orbit around the nucleus of an atom in orbital shells. Electrons in the outermost shell are called valence electrons. These electrons can jump from one atom shell and start orbiting on another atom shell. And also, if voltage is applied to a material, these electrons are the ones that flow. Protons and electrons carry charges. Protons carry positive charges and electrons carry negative charges. Since unlike charges attract each other while like charges repel each other, the two charges, the positive charges found on protons and negative charges found on electrons, are unlike, they attract each other. Since protons are contained inside the nucleus, they can't move. They attract electrons toward the nucleus so that the outermost electrons can jump to other shells of nearby atoms. The degree to which electrons are held by the nucleus in a material is the resistance of that material. We have three types of materials grouped according to the degree to which electrons are attracted by the protons in the nucleus of atoms. That are conductors, semiconductors, and insulators. In conductors, electrons are loosely held by the nucleus of atoms. Electrons can easily break from the nucleus of one atom and begin to orbit on the shells of nearby atoms. Conductors are materials with low resistance. In insulators, electrons are tightly held by the nucleus. They can't even jump from one atom shell to another. These materials have very high resistance. In electrical, insulators are used to cover current-carrying conductors, so that flowing electrons are kept contained inside a conductor. Semiconductors are materials that lie between conductors and insulators. If we increase temperature to semiconductors, they become conductors, and if we reduce temperature to semiconductors, they become insulators. There are factors that we can adjust to change the resistance of these materials, that are cross-sectional area, length, and temperature. Let's look at each of the factors that affect the resistance of a material, while other factors are kept the same. Let's start with the cross-sectional area. The resistance of a material varies inversely with the cross-sectional area, which means that when the cross-sectional area increases, resistance decreases, and when the cross-sectional area decreases, resistance increases. This is because on large cross-sectional area, more electrons can flow at the same time due to more space, while on small cross-sectional area, few electrons can flow at the same time due to less space. Here we have two materials of copper conductor connected to the same voltage. One with a large cross-sectional area has more electrons passing through a point per second than electrons on a small cross-sectional area. When more electrons are passing through a point per second, it means low resistance. And if there are few electrons passing through a point per second, it means high resistance. Let's move on to temperature. Resistance changes with the change in temperature. Resistance of conductors increases with an increase in temperature, while resistance of semiconductors decreases with an increase in temperature. This is because electrons gain energy in form of heat and light to break from the nucleus and become free. An increase in temperature causes electrons to break from the nucleus and become free. Increasing temperature in semiconductors makes electrons available for conduction, thus reducing their resistance, while increasing temperature in conductors makes too many electrons available for conduction, as they already have free electrons. This results in increased collisions as electrons move, reducing their movement, resulting in an increase in resistance in conductors. Let's move on to length of a material. Resistance varies directly with length. This means that When the length increases, resistance also increases. And when the length decreases, resistance also decreases. This is because the material on longer routes is more than the material on short routes, so their total resistance is different, with longer routes having more resistance than short routes, which is why fewer electrons are passing through a point per second on a long route than on a short route. To get the actual resistance value of a material, we combine the factors in the formula. Resistance is equal to the product of resistivity and length divided by cross-sectional area. Resistivity represents the type of material. We have already discussed the types of materials earlier in this video, which are conductors, semiconductors, and insulators. Resistivity is resistance measured between two opposite faces of a 1 meter cube of material. Resistivity is used to show the resistance of a material at a certain temperature before it is affected by length, temperature, and cross-sectional area. That is why we say resistivity is a constant of resistance. Every material has its own resistivity. For example, the resistivity of copper at room temperature is 0.017 microohm. If we are to calculate the resistance at the same temperature where resistivity was measured, there is no need to include temperature in the formula of resistance. That is why we don't include temperature in the general formula of resistance, because in this formula, temperature is already included while resistivity was measured. There are devices designed to introduce a known value of resistance into a circuit, called resistors. Resistors are components designed to limit the flow of current. Every electrical appliance has a current rating. If too much current passes through it, it burns out. To prevent the burning out of electrical components due to excess current, resistors of the correct size are connected into a circuit. Let's find the value of the resistor we have used in this circuit to prevent the light bulb from burning. The light bulb has a resistance of 10 ohms, a current rating of 0.5 amps, and is connected to a 12-volt battery. We first need to find the total resistance required to have a current of 0.5 amps flowing in the circuit. Using Ohm's law, resistance is equal to voltage divided by current, which is 12 volts divided by 0.5 amps, we get 24 ohms. We need 24 ohms in the circuit to prevent the light bulb from burning. Since the light bulb has a resistance of 10 ohms and we need a total resistance of 24 ohms, the resistor should be 14 ohms. Resistance is measured in ohms using an instrument called an ohmmeter. To measure the resistance of a circuit or electric component, we first disconnect the circuit or electric component from the supply. Here we want to measure the resistance of the light bulb. The ohmmeter measures resistance using Ohm's law, which says that resistance is equal to voltage divided by current. The ohmmeter supplies current at a certain voltage, and the amount of current that passes through the component is then used to divide the ohmmeter supply voltage, giving the value of resistance. The reason for disconnecting the component being measured is that the ohmmeter is its own battery used to supply voltage and current to the component being measured. If we don't disconnect the component being measured, or switching off the component's power supply, the component's power supply will damage the ohmmeter and its battery, or the ohmmeter may give false results. Okay guys, this is all we have in this video. I hope you enjoyed it. See you in our next videos.